Hari Om. We continue with the terrestrial magnetism. Now we discuss something called magnetic elements of Earth's magnetism. Actually, they are the physical quantities which gives the magnitude and direction of the Earth's magnetic field it attracts. There are basically three physical quantities coming under this elements. One, angle of declination. Angle of declination denoted by theta. Actually, this angle of declination theta is nothing but the angle through which the geographic axis and the magnetic axis are tilted. Or you can define it as the angle between the geographic meridian and the magnetic meridian of the Earth. This value is not a constant, therefore it is found to be varying. So we are not studying any constant value for this one. Next one is angle of dip denoted by delta. Angle of dip or inclination. Actually, this angle of dip we can consider like this, that if this is the magnetic meridian, and suppose this is the geographic meridian. Then, if we consider the compass needle kept at this particular point, you can find that the magnetic needle will be pointing along this direction. Suppose this magnetic needle will be aligning along this, means that the needle shows the magnetic field of Earth at the place. So this is the direction of the magnetic field at the place. Then, if the needle aligns along this way, then you can assume an angle here between the horizontal, this is the horizontal, and the net value of magnetic field at the place, and this angle is called angle of dip at the place. Now, if I assume that over here, for example, if this is the magnetic field lines coming out from the magnet of Earth and going into, and if I take another one and it is starting from here and going like this, suppose, okay, then as you take this magnetic field line going like this and going back to into, at any place you can find the magnetic field, as the tangent drawn at the place gives the direction of the magnetic field of Earth. So if I assume the place over here, you can find that the magnetic field will be directing along this way at this particular point, and let that be B. And that is taken here as B. Then this B can be resolved into two, one along the horizontal and another along the vertical. Then the angle between this B and the horizontal will give you the angle delta. That value is shown over here. So this is your horizontal component of Earth's magnetic field. and this is the vertical component of the magnetic field at the place. Or this like a magnetic meridian of Earth. So what is angle of dip? It is the angle made by the resultant intensity of Earth's magnetic field with the horizontal component at the place. Now from this one you can find that BH will be equal to B cos delta, and the vertical component will be equal to B sin delta from this one, such that B equal to root of B x square plus B square, means squaring and adding these two to get B value, and tan delta, tan of angle of dip will be equal to B vertical by B horizontal. So these are the equations you are supposed to remember out of this part. So these are the equations relating to Earth's field in terms of angle of dip. Okay. And the third quantity coming in the magnetic elements is that BH, that is horizontal component of Earth's magnetic field. So angle of declination, angle of dip, and horizontal component of Earth's magnetic field are the magnetic elements of Earth's magnetism. Now a little more points about the what you call angle of dip. This angle of dip is found to vary from place to place. You can see the value here is coming this much, but if you take the value over here, you can find that the B here will be around this way. Along this way means it is parallel to the ground. That means delta at this point is going to be 0. This point means it is coming where? At the magnetic equator. So magnetic equator delta will be 0. And what about the magnetic pole? You can see magnetic pole is coming normally into, and here from here normally out. So normal to the ground, therefore at these 2 points magnetic poles delta will be equal to 90 degree. Therefore angle of dip varies from 0 to 90 from magnetic equator to the magnetic pole of Earth. Yes? So these are the main factors you must know about the magnetic elements of Earth's magnetism. Equation for Earth's field, equation for angle of dip, declination, and horizontal component of Earth's magnetic field. Okay.